Hey guys, so in this video we're going to talk about simplifying radicals. First of all, let's talk about parts of a radical. So this symbol should look familiar. This is literally just the radical symbol. Inside the symbol, this is called whatever number or letters are in here are called the radicand. Between the check mark, if you will, is a number. This little number is called the index. And then the whole thing is called a radical. So, everything has an opposite. The opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite, or here, let's not use in, the inverse. The inverse, if I have x squared, is taking the square root. The inverse of cubing something is taking the cubed root. Inverse of the fourth root, inverse of something to the fourth is the fourth root, and so on and so forth. So, the index, this is telling you how to undo that number. Okay, so square root of 4, most of you know that. Square root of 4 is 2. But why is it 2? So the square root of 4 is 2 because the index is technically a little 2. Which means we're looking for what times what gives you 4. Well, 2 squared gives you 4. And the square root and the square cancel, and all you're left with is a 2, so that's your final answer. So now let's move on to an example like the square root of 100. So square root of 100 is 10. Hopefully you guys know that. But I want you to show your work to show that you understand the process. So square root of 100, we're going to do this twice, because there's a couple ways for your work that I will accept. So the square root of 100 versus the square root of 100. So first of all, one way to do it is just looking for perfect squares. So what times what multiplies to be 100? Now I know I'm asking for 2 because the index, nothing is written here. So we can assume it's 2. So 10 squared is 100. And then the squared is canceled out by the square root, so I'm just left with the 10, and so that's my final answer. Now I'm going to give you more complicated problems later, so what some students like to do is just write it out the long way. So maybe you don't even realize that it's 10 times 10, maybe you think, oh, 2 times 50. We'll keep factoring. So we're going to bring down our 2 because that can't be factored more. And then 50 is the same as 2 times 25. Now because my index is 2, that means I'm looking for 2 things being multiplied together. So I can take out a 2, and then I'm left with 25. And 5 times 5 is 25. My index is 2. Since I've got 2 things being multiplied together, I'm left with 2 times 5, which is 10. So the alternative, this is a lot more work, but a lot of students like doing this because they don't make mistakes. So square root of 8. We'll do it twice again. So what times what multiplies to 8? Well, 2 times 4. Now again, what you need to focus on is the index. What is written here? Since nothing's written here, it means it's a 2. So I'm looking for 2 things being multiplied together. Not 2 things, 2 of the same thing. Sorry. So these aren't the same, so I need to keep factoring. And then I have 2 times, well, 4 is the same as 2 squared. So because this is 2 times 2, my 2's cancel. I can put a 2 on the outside, but this 2 stays inside. That's my final answer. If that doesn't make sense, you can try showing your work this way. Here, I'll do a different color. So what times what multiplies to 8? 2 times 4. And then bring down your 2. What multiplies to 4? 2 times 2. Now because my index is 2, remember if it's not written, it's the same as 2. That means I'm looking for 2 of the same thing. So I've got 2 2's being multiplied together. So I can put a 2 on the outside. And then I've got this 2 left inside. So 2 root 2 is my final answer. Oops. Example 3 is the square root of 48. So why don't you pause the video and try to do this on your own. First thing you need to do, what times what gives you 48? Actually, you know what? The first thing you need to do is look at your index. There's nothing written, which means my index is 2. So I'm looking for 2 of the same number being multiplied together. So what multiplies to 48? Well, 6 times 8. These aren't the same number, so I'm going to keep factoring. What multiplies to 6? 2 times 3. What multiplies to 8? 4 times 2. Now if you want, if you notice, I already have 2 things being multiplied. And I'm looking for groups of 2. So what I could do is put it 2 on the outside and then keep factoring. Well, 3 can't be factored anymore. And what multiplies to 4? 2 times 2. Since I have another 2 of the same being multiplied together, I can put one on the outside. So I've got 2 times 2 times the square root of 3, or 4 square roots of 3. And that's my final answer. Now another thing you can do is cubics. So if I have the third root, that means I'm looking for 3 of the same number being multiplied together. Now a common mistake is to not rewrite this 3 in the index, so be careful. But we ask ourselves the same question. What times what multiplies to 27? Hopefully you're thinking 3 times 9. And then we don't have 3 of the same thing being multiplied together, so we keep factoring. Bring down your 3, and then factor your 9, which is the same as 3 times 3. Now, our index is 3. We're looking for 3 of the same number, and we have that. So we can put a 3 on the outside, and then there's nothing left over, so we just leave it. So the cubed root of 27 is 3. Alright. So cubed root of 136, same idea. Looking for groups of 3. So what times what gives me 136? Well, 68 times 2. It is an even number. And then we need 3 of the same thing. So factor. What multiplies to 68? 34 times 2. Bring down this 2. Still don't have 3 of the same number, so we keep factoring. What multiplies to 34? 17 times 2. And then make sure you bring down these 2 2's. Now we finally do have 3 of the same number. Coincidentally, Actually, that's not a coincidence. Never mind, sorry. So we can put a 2 on the outside. We're left with the cubed root of 17. And 17 is prime, so we are done. So this cubed root of 136 is 2 cubed roots of 17. Now, as always, answers need to always be in simplest form. So, if I said, example, 2/8, hopefully you're saying, this is not in simplest form. So how do we get it in simplest form? Well, you just reduce, right? So 2/8 reduces to be 1/4. And now we're in simplest form, and so we're happy. Another example would be if I have 6 times the square root of 2 over 3. This is not in simplest form. So how do I simplify it? Hopefully you're thinking that 6 and 3, 6 divided by 3 is 2. So I'm left with 2 square roots of 2. And now it's in simplest form. Well, new thing, 2 over the square root of 7. This is considered to not be in simplest form. And this is tricky. So we don't want a denominator that is irrational. Remembering our classifications. So what we do is we rationalize it. So to rationalize it, we do some sneaky math. So I'm just going to bring this down. Original problem is 2 over the square root of 7. What we're going to do is we're going to be really sneaky, and we're going to multiply. Yeah, I'll do it in green. We're going to multiply by the square root of 7 over the square root of 7. And it's sneaky because basically we're multiplying by 1. Now, when we distribute, 2 times the square root of 7 is 2 square roots of 7. Now, the square root of 7 times the square root of 7 is the square root of 49. And that's where it's sneaky. Square root of 49 is 7. So, final answer is 2 square roots of 7 over 7. And we are done. And now our denominator is actually a natural number or a rational number. And that's it. So we'll work on this more tomorrow. And then tonight you are going to focus on simplifying radicals. So you've got the rest of the period to work on your homework.